Our first keynote speaker, I'm really pleased to introduce Dr. John Foley. Dr. John Foley is the director of the University of Minnesota Institute on the Environment, which is really a renowned institute both within the university, within the region, and within the country, who's gained a reputation for addressing really complex problems. And the complex problem that we're obviously facing today, one of the many, is feeding the planet in a sustainable way. Dr. Foley came to the university in 2008 after 15 years at the University of Wisconsin, and he's won numerous awards. When you read his list of awards, it's like, holy smokes. The National Science Foundation's Faculty Early Career Development Award, the Samuel C. Johnson Distinguished Faculty Fellowship Award, the McDonnell Foundation's 21st Century Science Award, the Presidential Early Career Award for Scientists and Engineers. Just a phenomenal accomplishment by Dr. Foley. And Dr. Foley's research group is specializing on these complex problems, complex global environmental systems, and their interactions with human societies. So I was really pleased when he accepted our invitation to come and speak with us this morning, because it's really a particularly important topic for us this morning. So would you please help me in welcoming Dr. John Foley? How do we feed a growing planet? How do we feed a growing world without ruining the planet? Dr. John Foley, please.
Thanks. Should be all set. Great. Well, thank you very much, Bob, for the kind introduction, and thanks for everyone for being here this morning. I know it's probably not that early for you folks, but it is for a lot of people, so it's great to be here. I also want to thank Bob for being such a great chair and host. He called me. I'll tell this little story before I begin. He called me on Friday and sounded a little concerned, and he said, "John, have you ever hung out with like large animal vets before?" And I had to assure him that, yeah, in fact, I married one of them. So don't worry, it's okay. I get it. My wife's a dairy vet from Wisconsin, so you know, it's not swine, but I kind of get this story a little. Yeah, so I moved here about 2 years ago, about the same time as Brett Favre, and so far Minnesota's working out pretty well for him too, I guess. But what I would love to talk to you about today, again, is this issue about, you know, how do we think about these very complicated issues they're really tough. There's no easy answer in what I'm about to say. But how do we address this huge issue that we face nowadays about how do we feed a world that's growing, but at the same time recognize what we're doing to the environment in the process and finding some middle ground that solves both problems? And that's basically the conversation I'd like to have this morning with you all. But before we do that, I'd like to kind of put it in context. We talk a lot about the issue of climate change, for example. And my background actually is in climatology. I did this stuff during my doctoral work and whatever. And a lot of people have said lately that, you know, this is the greatest problem, the greatest environmental problem in human history, climate change. Well, maybe it is. But there's some other issues too that we have to pay attention to. For example, we've already transformed much of the world. This is a picture of what the Earth looks like from outer space at night, showing all these incredible lights everywhere about, you know, where our cities are. You can even see oil fields, you can see fishing fleets, you can see burning in the Sahel in Africa. And we humans have done quite a lot to the surface of the planet. If we drop down a little bit closer and we turn on the lights, we can see a little bit more of what we're doing to our landscapes. Here's a picture of the Bolivian part of the Amazon basin in South America. And here it is in 1975. And if you look real close, you'll see a small road, basically a dirt road, with one lone little farmer out there in the middle of the jungle in the 1970s. Well, let's come back to the same exact place now in 2003, just a short time later. And we can see this has been cleared extensively. It's hugely cleared now. Now, a lot of you will know where that's for. This is, it turns out, I've been in this right about there. And this place is pretty interesting because it looks a lot like Iowa and Minnesota now. It's full of soybean fields. And the soybean fields, as a lot of you know, is used to grow feed for animals, and that's being sent to Europe and China for the most part. So this is pretty interesting. The animal business has gotten even into this part of the world. It's not just here in the Midwest. This has become a global phenomenon, which is also represented by how international this meeting is. Things are changing all over the world, not just in our backyard. So this is pretty interesting. But we shouldn't always be looking only at clearing land for agriculture. We're also seeing how our cities are growing too. This is a picture of Las Vegas in the middle of the desert here in 1973. And even after this mortgage crisis and everything else, Las Vegas is still the fastest growing city in America in the last few decades. And we can see this big green area in the middle of the desert. And so there's an issue there too. It isn't just agriculture, it's us living in cities and suburbs and so on. In this case, using a lot of water that probably isn't very sustainable either. Now, if we think that's kind of an issue, I'll show you one that's even more interesting. A little bit, this is really weird. This is the middle of Saudi Arabia and some of the most dry desert regions on the planet. Here it is in 1986, looks like a desert. Here it is in 1991. You start to see these little green dots up here and here and here. And let's go look at it a little more recently. These are center pivot irrigation, like you would find in Kansas or Nebraska, or in other parts of the Great Plains. Here in the middle of the Sahara Desert, essentially, the Arabian Desert, that's mining groundwater that was from the rains that last fell here about 25,000 years ago. They're using this water to irrigate the desert for, in this case, wheat, which is really weird. And this water is going to be completely gone within about 5 years. So this is an incredible transformation, not only of land, but also of water. So it turns out that humans have used a lot of land, as well as what we're doing to our climate, in terms of shaping what the planet looks like today. So one of the questions we've got to ask ourselves when we think about land use and later water use, we have to figure out how much land do we use and what do we use it for? Well, if you ask most folks, and certainly if you live in the Twin Cities, you'll ask most folks, well, what are you using land for? And they're going to tell you, well, it's because of this stuff. It's urban sprawl, where our cities and suburbs are getting bigger and bigger. And that is true. They are, absolutely. This is a picture of São Paulo in Brazil, one of the largest cities in the Americas. But it turns out that, urban sprawl is really not that big an area. It's just that we live in it, so we see it every day. But in terms of area, it's kind of a myth that urban sprawl is the biggest use of land. It's not. It turns out that if we look across the world, the whole areas of the world that are covered in suburbs or cities is shown up in red here. I've even had to stretch the color scale for it to show up in the back of the room. While we live there, half of humanity now lives in one of those little red dots. We are now an urban species for the first time in history. Just a few years ago, 50% of the population suddenly became urban. That's never happened before. So suburbs and cities are growing, most of us live there, but when you add it all up, it's about 650,000 square kilometers of land, which sounds like a lot. It is. It's bigger than Minnesota, but it's less than 1% of all the Earth's surface. So in the grand scheme of things, it's actually not that big after all. It turns out that what's actually quite a bit larger is farms, agriculture. They cover a lot more territory, it turns out. These are all different farms around the world, all photographed from satellite, all with the same camera, basically. The same satellite is traveling around, so these are all the same scale. You'll maybe recognize a few. There's Minnesota right there. They're good, back 40 grid of farmland here in Minnesota. Same kind of deal in Kansas, but with irrigation. That's Germany, with older village landscapes with maybe smaller parcels of land, but people kind of living in a small town, but maybe everybody's a little bit of a farmer there. Maybe they all have a pig or a cow or something too. I love this one on the lower left. This is Bolivia. I think a geometry teacher came up with this one. It said, okay, you get from 0 to 15 degrees, and you get that to whatever part of pi you want. And that's pretty interesting. Rice terraces here in Thailand, down in the lower middle, which are some of the oldest farming landscapes still in production exactly the same way for about 1,000 years. And this is here in Brazil. These are soybean fields in Brazil. Looks a little bit like our landscape. But interestingly, Brazil has a federal law that we still don't have on buffer strips, which is pretty interesting. Brazil has somewhat more advanced environmental legislation than we do, at least at the national level, which is pretty neat. So we can look at all those farms and step back again to the globe and say, wow, agriculture turns out to cover a lot of land, quite a bit of land, it turns out. This is work that our research group and others have been working on for the last several years. But what it shows is in the green areas of the world, what's seen as green here, those are the world's croplands. These are the areas where we grow our cereals and grains and pulses and everything. That's really important, it turns out. And that area is about 16 million square kilometers, or about the size of South America, to put it in perspective. We have a South America's worth of land in row crops right now. An even bigger area, though, is used for grazing. The brown areas of the world, you can see mostly in drier places, a lot in Africa, the western US, Central Asia, Australia, the Pampas regions of South America. That's our grazing lands and pastures. That is about 30 million square kilometers, or about an Africa's worth of land. So we have about 2 continents worth of land devoted strictly to agriculture. You do the math on that, it turns out it's about 40% of the Earth's land surface. And it's the best 40%. It's the 40% that will grow anything. And we're already used it up. So that's quite extraordinary. We use 40% of the Earth's land surface. 1 of that percent is for cities and suburbs. The other 39 or whatever is used for farming and agriculture. It's really a huge difference. So if we look at that, we have to say, well, you know, depending on how you farm, we know from the Dust Bowl and other times and how farming sometimes happens in other countries, not so much here, that this can have some pretty big environmental impacts directly. For example, the biodiversity that used to live there. If you clear down a rainforest for new pasture, you're displacing the habitat of things that used to live there. It's just common sense. It's hard to deny that. At the same time, some practices, at least especially in the past, so it could sometimes lead to land and soil degradation, severe erosion, degradation of organic matter in the soil, and so on. And we all know the history of that. The U.S. has gotten infinitely better in that regard, although we've got a ways to go yet. But we're certainly farming a lot better than we did in the 1930s. So we've learned a lot in the meantime, which is good. So the environmental impacts are, you know, kind of depend on where you are and how you do it. But they're still there sometimes. But tied to this land use is an issue about water, too. Land and water are kind of inseparable these days, especially when it comes to food. This is a picture flying into Phoenix, actually, looking out the airplane window. And those of you who live in the Midwest will have to chuckle at this, because it turns out, at least from what I've been told, this is iceberg lettuce being grown in the middle of the desert here, irrigating iceberg lettuce in the desert. And you know, I'm wondering if this is being sold on store shelves in Minnesota. Probably is. Well, you've got to ask yourself, you know, what's this all about? Because this is a place where the water comes from the Colorado River. The Colorado River now is so used, mostly for cities, but also a lot for irrigation. We use up so much of this that it no longer flows even into the ocean. Now, here's a picture of the Colorado River from the 1950s near the Grand Canyon. This is, instead of using a hydrograph to show you the data, but the same idea. This is the same time of year, same exact location during a normal year. This is not a trick photograph. And that difference is water being used to irrigate golf courses and lawns, but also vast amounts of agricultural land in the middle of a desert. So this is a pretty big deal if you look at that. You have to think about that. You want to see an example that's even more dramatic, though, we just go to Asia. Here is in what used to be the Soviet Union's regions of Kazakhstan and Uzbekistan. Here in Central Asia, we see the Aral Sea. This is pictured in 1973 now. This is the time that we're looking at this. The Aral Sea really shouldn't be there, though, because it's surrounded by desert. It doesn't rain very much here. It's a very dry place. And it's formed because there's a river up about here, where my laser pointer is, and another one down here, that are draining snowmelt from mountains that are way, way to the east, about where I'm standing. Imagine I'm a bunch of mountains right here, and snow is melting from the tops of my mountains, dribbling down into the Aral Sea over there, filling up a big basin in the middle of a desert. Well, the Soviets started, in the 1950s even, started to divert those rivers to irrigate the desert, mostly to grow kind of not very good quality cotton, as it turns out, in Uzbekistan and Kazakhstan. And you can imagine what happens if you divert the water supply of the Aral Sea. It starts to shrink. Here it is in 1986. Here it is in, where are we, 1999. Here it is in 2004. And here it is about 6 months ago. Now, those of you from Minnesota or Wisconsin, now this is a huge inland sea, bigger originally than most of our Great Lakes. Now imagine that's your cabin on the North Shore, okay? How are you going to feel about Lake Superior moving about 150 miles that way? That's a pretty big deal. Not to mention the fact that the Soviets did biological weapons testing on what used to be a remote island that you can walk to now. That's an interesting story I'll tell you about later. But what's really kind of scary, this is a picture from on the ground that Al Gore took. And this is something he took when he was in the U.S. Senate years ago. These are the old fishing fleets of the Aral Sea. They've been abandoned. They've even tried desperately digging canals to float them into the remaining areas of water. But they eventually gave up. Now, I don't know about you, but I kind of look at that and say, this is just crazy. But I worry about future archaeologists or, people are going to dig this stuff up in a few hundred years and wonder about us, saying, well, what were you thinking? You dug up, what the hell? You turned off the water supply to the Aral Sea. What did you expect would happen? Of course this would happen. So this is a very, very kind of sad situation, but it's repeating itself in many places around the world where we no longer sustainably use our water supplies, even when it's staring us in the face. So land use and water use are pretty big issues. And it turns out that agriculture, again, is kind of the giant in the room. While we humans use a lot of water in our homes and industry, irrigating crops and livestock as well, but mostly it's crops, use about 70% of all the water we use around the world. And as we know too, that agriculture sometimes, not always, but sometimes can be one of the big kind of sources of some pollution in certain water bodies, depending on how you farm too. So both on the supply and the quality of water, we have to be thinking very seriously about how we farm, because we can see some really bad examples around the world that we don't want to follow. So those are some pretty big issues. So we talked about land use and water use, and I started off a little bit about climate change, but I want to get back to that because it turns out that agriculture has a role here too. It's kind of interesting. It turns out of all the greenhouse gases, carbon dioxide, methane, nitrous oxide, the greenhouse gases that we're concerned about building up in the atmosphere that might be leading to more serious climate change, it turns out that agriculture plays a role here too that often isn't appreciated. It turns out that agriculture is about 1/3 of all the Earth's emissions of greenhouse gases comes from land use and agriculture. And that's pretty interesting. And it turns out that that's even larger than all of the world's transportation. All of the cars and planes and trucks in the world are 18%, but agriculture is 34%. That's pretty startling. It's more than all of our manufacturing, all of our electricity, all of our industries. So it's really a very big player. Now, a lot of people, especially people who aren't in the ag business, people who will read Michael Pollan or whatever, they're going to have ideas about this. They're going to say, oh, I know what that is. That's about food miles. That's moving food from one place to the other. Or it's all the chemicals we use in agriculture, or the energy used in combines and tractors and so on. Well, nope, actually that's a myth. Those are totally not true. Those really don't contribute very much to greenhouse gases. Almost maybe 1% of all that is due to these three things. It turns out that a lot of it is due to particular farming practices, many of which not even in the United States at all. And it's really tied to things like deforestation. Clearing a rainforest and burning it down is a huge contributor of greenhouse gases. We don't do that in the United States. But other places are. So we have to look at the comparative advantage or disadvantage of agriculture based on that. They're also, of course, from not your livestock, but others. Rice and cows basically release a lot of methane. So we have to worry about that a little bit too. There are ways we can play with animal feed and how we raise animals, raise cattle that could have a major impact on that, or new varieties of rice that could maybe not release as much methane and be more productive. That'd be great too. As well as nitrous oxide coming from fields that are maybe over-fertilized that get very, very wet. So again, it isn't going to be food miles or chemicals used in agriculture. That's not the culprit in the climate change issue. It's these things. So make sure when people start blaming agriculture for climate change that they get their facts right and point the science to where it actually is. So we do have some issues, but they're not always what we think they are. So that's pretty interesting. So agriculture does have some pretty serious environmental footprints. In water, in land, greenhouse gases. I didn't even talk about nitrogen and phosphorus or biodiversity. But these are pretty serious issues. These are things that, in the environmental world where I'm from, we have to pay attention to pretty seriously. But, and we can't escape the conclusion that agriculture is a major force in shaping the planet today. There's just no other way to do the math. It's hard to avoid this conclusion. So agriculture does affect the planet today. It has a major environmental role. But, let's not be fooled about this. Agriculture is absolutely necessary, too. I mean, how many of you eat, right? We all eat, right? I think about 6-7 billion people would just raise their hand right now if we asked, do you eat? Or, would you like to? Of course, feeding the world isn't optional. Agriculture is not optional. It's one of the most important pillars of our civilization. There's absolutely no way we're going to give this up. So what we have to figure out is smarter ways to feed the world, but also pay attention to some of these significant environmental issues. And hopefully, and I think we are making some really good progress on that. So let's talk about that. Oh, wait. Before we even get there, we have to remember, too, that not only do we have to feed the world now, we have to figure out how to feed it indefinitely into the future while the demand is growing. Demand for agricultural products, as you all know, is going up astronomically. It's incredible, especially in the last decade. We're starting to see some very serious issues about this. Well, why is it going up? Well, it's going up for 3 basic reasons, and you all know this. It's not rocket science at all. One is population growth. We are adding about 70 to 80 million people a year to the planet still. This is the course of human population over the last 10,000 years or so. Here we are right about there. We're just about hitting 7 billion people today. And we're about at the steepest part of this curve, and we're headed towards 9 billion before we probably will settle down. So we've got about 2.5 billion people to go before the population will level off around 2050, we think. Who knows, but that's the current projection. So population is going up, which is a really big deal. Another issue, of course, is very much in your industry as well, is people generally around the world, maybe not, the US, we've been eating meat a long time, but around the world, more and more people are eating meat, which for a lot of folks is a very good thing. A lot of people need more protein in their diet. This is a good idea. So, well, that's a pretty big deal because more and more of the Earth's landscapes, this is a map of the world showing where our farming land in just crops, let alone pasture land, is devoted to growing animal feed in red. The red areas of the world are where crops are fed to animals. And the blue places are where crops are fed directly to people. And there's still a big divide between the richer parts of the world and places that are now developing. So it's very, very interesting. Western Europe, North America, primarily we're growing mostly animal feeds in our row crops, but everywhere else is growing human food directly based on a more vegetarian diet. So we're going to see this shift to have more oranges spreading all over the world as we have a more increased middle class around the world, and along with that, an increase in meat diet. This is inevitable. So we have to think about that too. So population, increasing meat consumption, and of course the pressures on energy too. We have a significant interest now in bioenergy and biofuels. Now biofuels have gotten really controversial in the last few years, as you can imagine, because of some maybe environmental impacts of biofuel production and so on. But you have to think, even as an environmental person, you have to think of the end game. We don't really have a choice. We do need a sustainable liquid fuel eventually, and the only one that we can probably think of is biologically produced. And it's probably going to have something to do with agriculture. So as oil begins to become more scarce long-term, as oil prices shift up, we're going to see increasing interest in bioenergy too. So population, meat, and energy are really coming together to put tremendous pressures on agriculture. And we're looking now at possibly having to double global food production by 2050, at least. And we've doubled global food production 6 times already in human history, but we'll have to do it one more time. And the last doubling is always the hardest. But that's what we're facing now. So that's huge. How are we going to meet this challenge of doubling global food production in the future? Well, we have a couple of options. We could farm more land. But as I mentioned, the amount of farmland we use on the left is basically all the good productive land we have, except some of the land that may be remaining in rainforest or maybe in very sensitive savannas and places like that, where they would have tremendous ecological cost, as well as maybe politically impossible anyway. So I'm not sure this is a great way to go. We don't have another Australia to discover somewhere of frontiers or the Great Plains. We've used up the frontiers. The good agricultural land has been used. There isn't that much left. What we need to do is figure out how to farm our existing lands better, more productive, less impactful on the environment. We have to get a 1-2 punch here, a double win. Well, how are we going to do that? I won't bore you with the details, but our group and others are tracking this very, very carefully. For example, looking at this is the production of corn around the world, and like on a bushels per acre basis. We can see areas that are really productive, like in the upper Midwest, that are in green, places that are less productive in kind of brown. We're comparing that to what the potential productivity of corn would be in different climates and soils based on some of our analysis of this. And the bottom line is this picture showing what the yield gaps around the world. We here in the upper Midwest, for example, in Western Europe and China and other places, have already seen massive improvements in agriculture. We're getting the best yields that are biologically possible right now until we have better genetics. So this is probably as good as we're going to get. But there are a lot of places in the world. We see here in Mexico, for example, really high production of new hybrid varieties next to older open pollinated varieties that are very much less productive. So we see technology makes a difference. We see in West Africa, East Africa, huge differences in productivity between, let's say, Malawi and other parts of East Africa. Or here, Eastern Europe, that's really interesting. I know we have colleagues here from Eastern Europe. I'd love to hear from you about this. But during the Soviet era, we had about a factor of 4 difference in yield between farms in Eastern Europe behind the Iron Curtain and the exact same farm in Western Europe, mostly because of management, genetics, institutions, markets, and so on. That still happens even today, years after the collapse of the Soviet Union. So there's a lot of opportunity around the world to bring farms up to modern practices, tie them to global markets, and significantly boost production without using another acre of land at all. So this is a really good win for food and the environment. We don't have to clear rainforest. We just fix up the farms we've got, and we could do a lot more. So that's pretty interesting, and there's tremendous opportunities around here. So we have to, again, meet, this is going to be one of the greatest challenges of the 21st century. How do we meet the growing demands for food around the world with population and diet and economic growth and energy shortages, while we're also lowering the environmental cost of how we do agriculture today? Well, we're going to have to figure that out. Now, a lot of you, and I'm probably stepping on some sensitive territory here, but a lot of folks in the greater public will say, yeah, but I've heard this before. I've read about, about organic food, and I go to the farmer's market and so on. I grew up on a little organic farm in Maine, actually, and I like farmers markets and so on, but we have to ask scientifically, can local organic agriculture automatically solve all these problems for us? Is the solution right in front of us? Well, let's see a bit. Well, there's a kind of idea out there that local food is better for the environment than distant food. Food that goes on a truck is somehow worse because you had to put it on a truck and use energy to move it around. So is it better to buy food grown within a 50-mile radius than a 5,000-mile radius from your home? Well, that's an idea that's put out there a lot. You hear it every day, but it turns out it's not really true. Of all the energy and greenhouse gases tied into growing food, transportation is not really a major part of it. It turns out the average American uses much more fuel driving to the supermarket or driving to the farmer's market, whichever you prefer, than the farmers did, getting it to you. Okay, get in the SUV, pop into one bag of groceries. I don't know any farmer who does that. They usually fill the truck up to the top. They're pretty efficient, right? So it turns out that the more volume you have, even if you drive a long distance, kind of cancels out the distance effect. Ironically, it turns out food you buy from like Walmart might have a lower carbon footprint for transportation than a farmer's market. Even though they traveled further, they deal in much larger volumes. So it's not exactly what you think. So again, this might not be completely true. We have to look a little deeper than that. We also have to look at this question of, can organic agriculture feed the world anyway? A lot of people think that it does. We can all buy organic. Well, what fraction of the world's calories are currently produced by certified organic? Anybody know? How much? You're right. A gentleman over here had it exactly right. Sometimes I hear, 5%, 10%, 20%, all thinking, oh God, I bet that's kind of low. This gentleman was actually absolutely right. It's less than 1%. The last number I saw was 0.6%. Maybe it's 0.7 now, because it is growing, but it's still less than 1%. And if you think about calories and protein and things that a lot of people need around the world, organic broccoli at Whole Foods is not really feeding the world right now, okay? I wish it could. That'd be great, but it's probably not. And a lot of the certified organic is, ending up in kind of rich white people in North America and Europe right now. It's not feeding the world. Maybe it could, but right now it's not. So I think we have to kind of look beyond that too a little bit. What we have to do, I think, though, is maybe, and this is my personal opinion, not a real scientific one, is it would be really good if we could reduce the kind of rhetoric between organic on one side and commercial on the other. Right now there's a bit of a war going on here of words between these two camps, and it's not very constructive, because I personally think there are some good ideas on all sides of the spectrum, but it'd be much better if they could collaborate and find some common ground between them, because frankly the world needs it. So you know, if we have to choose, this is the artificial world I'm making up in my head, to have, you know, I have to choose Monsanto or Michael Pollan. I'm going to ask, can we have a third option here? Because I think there's some good wisdom on both ends of the spectrum here. Have friends in both areas, you know, that we might learn a thing or two from. So how do we take solutions out of these sides, not rhetoric, and try to figure out how do we use precision agriculture and new crop varieties, use maybe GMOs for some things, depending on how nervous you are about that, irrigation practices that could be better, better tillage practices, maybe shifting dietary practices. I'm sure you'd love it if people ate a lot more pork. That'd be great. Could we have some more economic incentives for farmers to do what they think is right without getting in their way, etc. So how do we find some common solutions here, which I think are desperately needed? But if we just have this back and forth war between these two camps, nobody wins. That's really silly. If you're my, you know, you're over here on the organic side and you just think tomorrow, you know, agricultural business will just disappear, I don't think so. That's not a plan. If your plan is the other side loses and goes away tomorrow, you're in for a lot of disappointment, okay? We need a better plan than that, one that brings people together and doesn't divide them. So that's where we need to be, I think, where we might need to have kind of another green revolution. Minnesota is the home of Norman Borlaug. We're very proud of him here, who launched the first green revolution. We need to now have a second green revolution that covers all of the world, including Africa, and really also pays attention, as we've learned more and more about agricultural issues connected to the environment, how we revolutionize not just production, but environmental safety and security as well. So I have a few points I'd like to make that I'll just show you in a very quick video just to kind of summarize rather than listening to me anymore. We made a very short little video which we put on YouTube, and I'd be happy to send to any of you if you'd like it. It's also on our website, but I'll just show you this for it's about 3 minutes, and then just a couple last words and we'll take some questions. So here's a little video for you to look at. That video actually resulted from a bet I lost where somebody said, I bet I could give your talk in 3 minutes. And I'm like, no. And they did, and I can just send the DVD now. I don't have to go anywhere. But I guess as I started out saying, this is not an easy conversation. As you know, that we've had a lot of, I think totally unnecessary, but maybe understandable tension between maybe environmental interest on one side and maybe organic over here and other agricultural interest over there. But we all face the same challenges. We all want the same things. We want a planet where everyone is fed. We don't want a planet where anyone is hungry. We have to deal with increasing demand. At the same time, we all know that we have to deal with some of these issues, legacies of agriculture around the environment. We have to figure them both out. Everyone in this room, I'm sure, wants those both to happen. So the question is, how do we face these enormous challenges ahead together? And I think that's a really important point. We have to figure out how to feed the world, provide food, fiber, feed, and fuel to 9 billion, maybe 10 billion people, while simultaneously protecting our planet's ecosystems and other natural resources for the future. We all want that. And guess what, though? We have to get it right because we only get one and only try at this. And that's the work ahead of us, and that's the work that I know all of you are doing in your work today, too. And so with that, I'll just stop and see if we have some questions. But thank you very much for having me here today, and I look forward to any conversation or questions you might want to have. Thank you very much. So people are texting their questions away, I imagine, right? That's going to be cool.
To remind you, if you would like to text in a question, Monsi's receiving them. We'll take as many as we have time for. 612-850-0019. Question for you, John.
Yeah.
Can you quantify the statement that agriculture is a major source of water pollution?
Yes. In terms of water pollution, it depends. It's very specific to where you are. That is not a blanket statement. It does not mean all forms of pollution. That's absolutely not a universal truth. But to quantify that further, for example, particularly in terms of nitrogen and phosphorus, fertilizer use, for example, has, and most of this is not livestock per se, it's mostly on-field. Fertilizer use is mostly what's seen as the problem here, but other issues as well. We've already more than doubled the amount of flows of nitrogen and phosphorus to the Earth's environment. So we know, for example, about nitrate pollution and hypoxia in the Gulf of Mexico, for example, and other systems. We see phosphorus mobilized into lakes. I lived in Madison, Wisconsin for a long time, where the lakes in Madison, about 70 to 80% of the phosphorus pollution in the lakes came from local agricultural runoff. And there is, we can work on the lawn chemicals, we can work on other industries and things that are more in the urban areas, but the elephant in the room is often agriculture and a lot of these things. And it's kind of unavoidable. Nobody's intending to do this, but when you cover such a large amount of land, rain falls on that land, no matter what you do, it's going to have a bigger impact because it covers so much real estate. It's just a matter of arithmetic. So that's kind of where we're coming from on that. But more specifics depend on where you are and what's going on.
Some of our veterinarians were in Washington, D.C. last week visiting with our elected officials, and I heard some comments back that they came back somewhat disillusioned because...
From Washington? Oh my God. How could that be? Sorry.
They felt like our elected representatives weren't really paying attention to science and more responded to emotion.
Yeah.
How do we get beyond emotion and sit at the same table and talk, as you are suggesting, about science and reality, let's call it?
Yeah, well, I'm all for that. Now, I think that's an unfortunate thing that we see as well in my world, that our elected officials are very polarized right now, unfortunately, and we as a society seem to get that way awfully quick. And that's a shame, because that's not how democracy is its strongest. I mean, this is definitely taking off the scientist hat here, but I think all of us are just rolling up our sleeves. Maybe the Midwesterners in the room, will be feeling pretty good about that, because I think there's a tradition in this part of the world to try to solve a problem rather than win an argument. I feel very strongly about that. I'm willing to lose all the arguments in the world if we solve a problem. And I think a lot of other folks are too. We don't need people throwing bombs at each other, verbally back and forth between left and right or environment and agriculture. That's ridiculous, because we all share the same world. We have to make this work. We need food. We need a clean environment. The only way we're going to do that is we bring these folks together. So yeah, I'm afraid I can't give much advice to Washington, but you know, it doesn't surprise me at all because we're seeing the same thing. But this is where, again, you know, all of us, you know, most of you are, you know, veterinarians or in the agricultural business. You have a lot of power in how this works in your community and how it works in your networks. You know, environmentalists too. You know, a lot of us should be going on your rounds with you and trying to understand your industry better. Maybe we could have more dialogues back and forth between these kinds of worlds, because that's ultimately what's going to change it, is to really make sure we respect each other first. That's the basis of good dialogue. So that's maybe a starting point.
The U.S. was recently surpassed by China, we understand, as the total emitter of greenhouse gases.
Yep.
The U.S. was first. We're still first per capita, but as a total emitter, China is the lead. But in the U.S., where does what's agriculture's role with regards to climate change, greenhouse gases within the U.S.?
Right. Within the estimates vary a lot, but it's compared to the global numbers, it's smaller. As I pointed out, that globally the biggest of the global emissions, what ends up in the atmosphere, about a third, let's say, 30 to 35%, depending which numbers you look at. Of those emissions come from things related to agriculture. But the big three, again, are pretty interesting. One is deforestation. Well, we in the U.S. are not doing that directly, although some of the things we buy maybe come from that, but mostly not. We mostly export agricultural products. So that's good. That's not us. So that means Brazil and Indonesia have pretty big emissions in that area where we don't. Another big area is rice and cattle, releasing methane. We grow some rice in the United States, but not as much as Southeast Asia, other places. And on the livestock issue, well, we could do better. We know, for example, that the feed mixes that we feed cattle can affect their digestion, and with ruminants, and how much methane they release could be adjusted, perhaps by changing diets, maybe breeding, and so on. So we could do better in that. And also that could simultaneously enhance milk production and meat production. When cows are releasing a lot of methane, they're burping up methane. That's often because of, like, what am I telling you for? You guys are the experts on this. I'm just getting into very dangerous territory here. But from my understanding is that's digestion that didn't work very well. So if cows are digesting food better, they don't release as much. But I'm sure somebody here can correct me on that. You're the experts on that.
Why can't we just limit population growth?
Well, good luck with that. It's one of the most intrinsic human rights we have. And secondly, that's not the biggest lever right now. While we're, you do the math on this, we're 7 billion today, we're going to increase to 9 billion, so that's what, a 25% increase, let's say, okay? 2 billion people. But I was talking about doubling, 100% increase in food production needs by 2050. And interestingly, the population that's growing the most in the world are generally the poorest people in the world who don't eat very high in the food chain. So interestingly, the biggest lever in the world right now is diet change. That's bigger than population. And a lot of it is going to be tied to meat, but also other things. So, and pork, of course, you all know, is actually one of the most efficient sources of protein from livestock. It's extremely efficient. So other than like tilapia, I don't know anything that's that efficient. So, our appetite for beef may be kind of an issue, but pork is a lot better. So, this is a common ground you have with people concerned about environmental issues. So that's one of the big issues. Population alone isn't going to be enough, and even if we did, we have 2 billion people right now under the age of 16. This should scare the heck out of most of you. This is really scary. I have 2 of them at home. Imagine that we have 2 billion kids in the world today who haven't had children. Half of those 2 billion are girls. So what they decide to do is going to be extremely important. And most of that's going to be about developing education, fertility clinics, access to education, economic power, especially in poor countries. So that's going to be really important. We can maybe do something about population, but diet's going to be probably the showstopper in the next couple of decades too.
We've had such difficulties across the world with GMOs and GMO crops and resistance to nuclear power, which, both of which you could argue on the surface, there's some obvious solutions.
Yep.
So what gives you sort of optimism as you look ahead?
Yeah, that's a really funny thing. I wish I knew the answer to that, because it's really interesting. This question is very, very interesting because, in my personal opinion anyway, because we've had technological change possible from nuclear power, genetic modification of organisms, biofuels, ethanol in particular. And what's really interesting is you see this kind of repeating pattern of kind of a boom-bust cycle happening maybe. On one hand, in the early phases, you have a lot of investors in these new technologies who, let's face it, venture capitalists aren't always interested in having the technology succeed. They just want it to become more valuable from when they invested to when they sell, right? Buy low, sell high. So you have a lot of people who have an unfortunate kind of tendency to overhype a technology, to say this is the solution to all of our problems. It'll be so cheap you won't even have to meter electricity. This is what they said about nuclear power years ago. And GMOs would solve all of our health problems, all of our environmental problems, etc. Biofuels had some similar claims made early on. And so there are people kind of standing to make some bucks in the early age, of the technology that might be overhyping a little. But then, you put the technology out there, and then there's kind of a backlash from the often environmental community. I kind of don't like that sometimes. But a bit of a neo-Luddite, no, we don't like this anymore, who don't ask the really good question like, so you're saying coal is a good idea, that we should just stick with coal? That's it, and we're running out of oil, but we don't need to find a substitute? Tell me what your option is. So that's the challenge I put back at the environmentalists, saying, I don't want nuclear power, I don't want GMOs, I don't want biofuels. And I look at, well, what in the heck do you want? Because we got to have food and we got to have transportation. Tell me what your solution is. And that's usually when it goes very quiet. So that's a really unfortunate thing. I wish I had an answer to that, but I challenge people on this. You don't like that technology? Well, what's your alternative? Tell me, how are you going to fix this problem? How are we going to feed 9 billion people? How are we going to get an energy solution that works? And how are we going to protect the environment? But you don't want this, 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 and this. It can be really infuriating. Believe me, environmentalists are some of the most infuriating people I know. I love them. I'm one of these people, but oh my God, we can drive people nuts. So go back in their face on this stuff. It's really important to have that conversation. I don't think there's an easy answer here, but we got to have the conversation.